So here we have fun space is odd parameter n with the body with the two statement. The first statement is comparison and equality operator if parameter n or the first parameter is an equality operator. So n equal 0, return space false, closing statement, then return space is even parameter n minus 1, closing statement, and then closing body of this fun is add. And the next would be fun is even parameter n with the body if parameter n equal 0, so it's comparison, return true, closing statement. Then the second statement is return space is odd parameter n minus 1. So we're doing arithmetic expression here as a argument instead of comparison operator. So note, granted, this is probably the most efficient way to tell if a number is even or odd, not to mention the bad things that happen if you pass a non-integer or negative number to them. Bear with me. So again, granted, this is probably not the most efficient way to tell if a number is even or odd. Not to mention the bad things that happen if you pass a non-integer or negative number to them. But bear with me. Now that the is-even function isn't even defined by the time we are looking at the body of is-add function where it's called. We swap the order of the two functions, then is-add function isn't defined when we're looking at is-even's body. So if we swap the order of the two functions, then the alternate would be true, which will the is-odd isn't defined when we're looking at is-even's body. Now note, some statically typed language like Java and C# solve this by specifying that the top level of a program isn't a sequence of imperative statements. So again, the imperative statements is the one that you are telling your module to do. So the top level of the program isn't a sequence of imperative statements. So that's how C# and Java do it. So it tells the module that this is not part of that sequence, so that you can use this as a global variable, so that you don't need to wait for is-add to be defined when you're looking at is-even body, or for is-even to be defined when we're looking at is-add. So instead, a program is a set of declarations which all come into being simultaneously. So it's a set of declarations which come into being simultaneously, just like a compiled program or a control program. It comes alive when it's in the memory. The implementation declares all of the names before looking at the bodies of any of the functions. So the implementation declares all of the names before looking at the bodies of any function. So you declare that at the top, since that is a set of declaration that comes into being simultaneously. it declares all of the names if we're looking at the values of any function. So we're just talking about function here, not method. Now, older languages like C and Pascal don't work like this. Instead, they force you to add explicit forward declarations to declare a name before it's fully defined. So the forward declaration are the prototype you would put so that you won't get an error when the program needs that um, function inside your function. So that was a concession to the limited computing power at that time. So because it's a limited computing power at that time compared to today, that you can just create many declaration and then have that occupy some space in memory and then prepare for it when the time comes. So they want to be able to compile a source file in one single pass through the text. So the reason for that is they wanted to be able to compile a source file in one single pass through the text. So they don't want to compile another one once it is in runtime, just like with what V8 engine does with a lot of its logic today. It does its compilation just in time. So those compilers couldn't gather up all of the declarations first before processing function bodies. So the reason for that is that those compiler couldn't get all the compilation that it needs to get before processing that function bodies because of the limited computing power at that time. Since making it a static error makes recursive declarations too difficult, we'll defer the error to runtime. So making it a static error makes the recursive declarations too difficult. Now we'll just defer the error at runtime. Since we also want to allow recursive declaration, we want to allow this and just defer the error at runtime instead of at compile time. So remember, before you can even be able to process a function, that dependencies or the function within its function should be able to be gathered by the compiler for it to process it. Now, it's okay to refer to a variable before it's defined as long as you don't evaluate the reference. Now, it's okay to refer to a variable, so just use it without it being defined as long as you are not evaluating it. Kind of like how you would not make it a parameter inside the function. So you don't, as long as you don't evaluate the reference of that um, variable. That lets the program for even and odd numbers work, but you get a runtime error in. So again, it's okay to refer to a variable before it's defined as long as you don't evaluate the reference, because remember the variable are evaluating some reference, so that's the program for even and odd numbers work, but you'd get a runtime error in. So here now you get you get to refer to a variable before it's defined or before it's declared in the fun even and then is odd. Now it lets the program for even and odd numbers to be compiled, but you'd get a runtime error because logically it wasn't able to get that from you. But that's fine, because if it's a logic error, it's really up to the user to define that. So the user has that open, has its leeway to define whatever he wants. If that's really what the user intended to do with the program, then that's okay. But for us, we would allow it. So here, print space A semicolon, then var space A equals code too late string semicolon. So we print first the A, and then before we define it, so that that's the reason why, like, printing something allows you to see if you already define an object or a variable to it. So here, this is a good example. Print space A semicolon, the next line var space A equals code too late semicolon. So as with type errors in the expression evaluation code, so as with type errors in the expression evaluation code, we report a runtime error by throwing an exception. So here we can organize something here. So instead of thinking that the errors at runtime is the result of expression evaluation, or instead of an error at runtime caused by a type error, what we would another category we would add is that undeclared variable. So our tools in seeing that undeclared variable is print, and with the with the type errors in expression evaluation code, we report a runtime error by throwing an expression. So the exception contains the variable's token, so we can tell the users where in their code they messed up. So the exception contains the variable's token or the undeclared variable. So this exception at runtime, so the exception really is an error. So the exception you would see in full stack ASP is an error that the program did not expect at runtime. So that exception usually allows you to define something that you would do in case it catch this error at runtime. So it's kind of like a try catch. If you prepare for that, then that's good. Your program could branch into that logic of the code. Now, the exception at runtime we would provide for locks will contains the variable token where the undeclared variables is. Or when it comes to type, where is the undeclared type or wrong type, we can tell the user where their code mess up. Interpreting global variables. The interpreter class gets an instance of the new environment class. So the interpreter class, the interpreter.java, will get an instance of the new environment class we created. So here in class interpreter, in interpreter.java, inside of it, we would add this private space capital environment because it is a class. Space environment equal space equals space new space capital environment empty parameters semicolon. So this is how we contain that class into a private method into a private method called environment inside the class interpreter. Now we store it as a field directly in interpreter. So again, we store it as a field. It's a method, kind of method directly in interpreter. So that the variables stay in memory as long as the interpreter is running. So we store it by doing this, by storing it as a field in the interpreter, the variables will stay in memory as long as the interpreter is running. So since you instantiate it along with the inside, as a field, as a method inside of the class interpreter, it will occupy some space as long as the interpreter is running. This is also what we meant by C not allowing this before, because it has limited memory. Now we can just do this, even if it doesn't do things immediately based on its declaration or control flow program. So since program consists of many declarations, we can just allow this. So we have two new syntax trees, so that's two new visit method. The first is for declaration statements. Now we need to produce a syntax trees. So that's a two new visit methods. So since we have two new syntax tree that we created, that will consist of two new visit methods. The first is for declaration statements. So we need to add this visit method for declaration statements. So we would add this after visit print stmt method in interpreter.java. So at override, under it is public space void, capital void, space visit var stmt. So this is the method name, parameter stmt.var space stmt. So its body has two statement, actually four statement. First statement, it defines a variable, object space value equals null semicolon, and then it has an if logic. So if parameter stmt that initializer not equal null, then its body would have this statement, value equal evaluate parameter stmt that initializer closing statement, then closing body of this if. Next statement, environment that define parameter stmt.name.lexim comma value, closing statement. Next statement, return null, closing statement, then closing. Now if the variable has an initializer, we evaluate it. If not, we have another choice to make. We could have made this a syntax error in the parser by requiring an initializer. Most language don't though, so it feels a little harsh to do so in locks. So again, if the variable has an initializer, we evaluate it. So the initializer expression. Then if not, um, if it's just declared, not defined, that's what we really mean by initializer expression. If not, we have another choice to make. We could have this syntax error in the parser by requiring an initializer. So most language don't require you to initialize variable though. You can just declare it without defining it. So it feels a little harsh to do so in locks. Now we could make it a runtime error. We'd let you define an initialized variable. So we could make it a runtime error though, that we could let you define an initialized variable, or a variable that's really not defined. There's no value, and then an initialized meaning that since you declare a variable and you didn't even define that in other parts of your code, meaning that you an initialized variable, you didn't use that in your app, so the system could report a syntax error or a runtime error for that. But if you access it before assigning to it, a runtime error would occur. So we could make it a runtime error. So to make it a runtime error, the requirements would let you declare a variable without defining it. But if you access that variable, since it was not defined, there's no value to use by the system, it's just a reference to something, to some value, then a runtime error would occur. Now, it's not a bad idea, but most dynamically typed languages don't do that. Instead, we'll keep it simple and say that lock sets a variable to nil if it isn't explicitly initialized. So most dynamically typed language don't actually do those kind of complicated things. So instead, in our language, we'll provide a value, the primitive value, the integer string, um, and then what do you call this? So an integer and string and nil, right? Those are the things that our compiler does, or interpreter rather. Hmm. Uy! Holy shit. Let's open it again because Robert. Hmm. So nil is one of our primitive types, if you will remember. Now, let's just go back to expression, to get grounded on what we are actually doing. Hmm. So the Lox language have this. Uh-huh. So the data types, the booleans, numbers, strings, nil. And then the expression would be arithmetic. So the arithmetic is part of the expression. So that's the first of expression that only works on numbers. And comparison and equality is an expression that always return a boolean. And then a logical operators is an expression the logical operators are the not that returns also a boolean, and the other two logical operators are really control flow. So this is still an expression. Our control flow constructs in disguise of expression. So it's just disguising as an expression, like true and false is false, true and true is true, like the and or in the logic gates. And then another part of expression is precedence in grouping. So all of these operators have the same precedence and associativity that you'd expect coming from C. So when we get to the parsing, we'll get more precise about that. In cases where precedence isn't what you want, you can use open and close parentheses to group stuff. So since they aren't very technically interesting, I've got the remainder of typical operator and auxiliary out of our little language. So note bitwise, shift, modulo, or conditional operators. So the ternary operator, the conditional operators are actually part of the expression. The shift or the bitwise, the modulo that we would use in the modulo that we would use in a, what do you call that, a fees bus is actually an expression, but they're not that interesting. So I'm not grading you, but we'll get a bonus if you implement that. And another part, so those are the expression part of the language. Primitive type expression, then statements. So now we're at statement where an expression main job is to produce a value. So a statement job is to produce a side effect, which is what the expression statement grammar we created. It's supposed to create a value from other parts of the app. Since by definition, statements don't evaluate to a value to be useful, they have to otherwise change the world in some way, usually modifying some state, reading input or producing output. So remember, a program is just a CRUD. A class just consists of many create, read, update, delete to a database. So those methods inside the class are just reading, updating, creating, reading, updating, deleting. And then those CRUD the statements don't evaluate to a value. Now, to be useful, they have to otherwise change the world in some way, usually modifying some state. So there's actually three things that you would think when it comes to a method inside a class. Not really input, process, output. Those are just the beginner level of thinking about it. But actually modifying or editing some state, reading input or producing output. Now you've seen a couple of kind of statement already. The first one is print quote hello comma world closing statement. A print statement evaluates a single expression and display the result to the user. So the print is actually a statement that evaluate a single expression and display the result to the user. So it does two things. You've also seen some statements like quote some expression semicolon. So those are also a statement. Now, a statement, just like print, can also evaluate a single expression and display the result to the user. It doesn't need to do a computation like an arithmetic expression, the equality, the comparison and equality operators, which always return Boolean value, or a logical operators, the not and the and or logic that also returns a boolean, or an arithmetic that returns a number value. It doesn't need to do those things. That's what a statement is. It could evaluate a single expression and then displays the result to the user. Now, you've also seen some statements like this: some quote some expression, semicolon. Now, it doesn't return any value, right? It's just a string. I mean, it doesn't execute some expression or arithmetic. It doesn't return number or boolean. It's just a string, as it is. So an expression followed by a semicolon promotes the expression to statementhood. That's why we keep saying that whenever we reach a semicolon, it it makes the expression that's supposed to evaluate something into just a statementhood. This is called imaginatively enough an expression statement. So this expression statement is also what we are keep creating, grammar with in the later chapters. So this expression statement if you want to pack a series of statements where a single one is expected, you can wrap them up in a block. So, okay. An expression followed by a semicolon promotes the expression to statementhood. This is called, imaginatively enough, an expression statement. Now, if you want to pack a series of statements where a single one is expected, you can wrap them up in a block. So here, this is what we are keep saying, like just a variable declaration or just a statement, a single statement outside of a block is what we are keep recursing now in our parser, the statement, the state and statement. So that's a single statement. So you can organize a statement using a single statement or a series of statement where you put that in a block. So if you want to pack a series of statement while a single one is expected, you can wrap them up in a block. So like this body. First print quote one statements, closing statement, then next print two statements, closing statements. Now blocks also affect scoping, which led us to the next section. Now this block, affects scoping, which leads us to the next next topic, which is the variables. Now you declare variables using var statements. If you omit the initializer, the variable's value defaults to nil. So this is remember our decision to omit the here in a state and statement chapter is actually leads back to here. This is one of the rules we have decided. Now, if you omit the initializer expression or the value to that variable, it defaults to nil. It's connected to how when blocks or a series of statements are affect scoping. This is also related to that. Now, note, this is one of those cases where not having nil and forcing every variable to be initialized to some value would be more annoying than dealing with nil itself. Like this, var space I'm a variable equal quote, here is my value semicolon, next line var space I am nil semicolon. Now once declared, you can naturally access and assign variable using its name. So once you declare a variable, meaning once you declare and then define it, you don't need to reassign that variable just like with const. You just need to use its name to refer to its value, such as var breakfast equal code bagel semicolon, the next line print space breakfast semicolon, the next line breakfast equal bnet semicolon, the next line print space breakfast semicolon, which return bignet string. Benyai rather. Can you tell, note, can you tell that I tend to work on this book in the morning before I had anything to eat? Now, I won't get into the rules of variable scope here because we're going to spend a surprising amount of time in later chapters mapping every square inch of the rules, or mapping every pixel to the rules. Now, in most cases, it works like you would expect coming from C or Java. Now, this is what we are talking about in this chapter, the statement and state. That's why it's highly related. Control flow. It's hard to write useful programs if you can skip code or execute some more than once, or doing recursion. You know, sometimes you want to execute this block of code more than once, or just skip it and branch to another. That means control flow. In addition to the logical operators, which is just an expression that returns a value we already covered, logs leaves three statement straight from C. Now, in addition for that logical operator which we get from C, logs also glyph, or get three statements of control flow from C. Note, we already have and or for branching, and we could use recursive to repeat code. So we already have and or for branching, since again that logical operator expression is just another way of it's just a facade into what really is a control flow. So what the logic gates under hood that thus is really a control flow for it's really a control flow for a program. Holy shit. Now, note, we already have an or for branching, and we could use recursion to repeat code. That's theoretically sufficient. It would be pretty awkward to program that way in an imperative style language, though, since our program, again, we keep saying that Lox is an imperative programming language. That would be weird to do that. So Scheme, on the other hand, has no built-in looping constructs, or executing the same code multiple times. It does rely on recursion for repetition. Smalltalk has no built-in branching constructs and relies on dynamic dispatch for selectively executing code. So an if statement executes one of two statements based on some condition. So these are the if statement we get from C as well. So it's part of the statement, kind of like part of the statement, because again, we have first primitive data types, expression, then statements, then variables, then control flow. But again, a control flow is also a statement. It's an if-else statement we get from C. So here, an if statement executes one of the two statements based on some condition. Like if parameter condition. So this is actually what you would see in an if statement always, or a while. Because in an if statement, you always see this parameter. So the parameter is actually a condition, and then inside is another statement, or of a series of statements for that block. So as you can see, instead of thinking of the program as just function within function, though that might be I mean, that might be reasonable as well. We could think of a program as a series of statement as well, like this, that for that statement, for that if statement, it has that parameter of a condition that could return a number, it could return a string, or it could return a boolean or just nil. That's why we have those in the condition. And then else, and then its body. Mhm. Now, a program could be a multiple function, right? It could be a multiple function that, inside it could have a multiple statement or a series of statements. So as you can see, this is where the interconnection came. And the variable, the statement, initialize expression referring to the variable executing the same is where the, complication happens. But bear with us. So a while loop executes the body repeatedly as long as the condition expression evaluates to true. So the condition is just an expression, right? The condition inside of this if is just an expression that a while loop will evaluate to true, or that condition. If that condition returns a boolean of true, then a while loop will continually executes the body. So here, for example, var space a equals to 1 semicolon. Now we define the variable a. Now while parameter or condition, so as you can see, it's a condition as well. Just like with if, you have this condition as parameter. So while with the parameter a less than 10, so while this is true, you have its body print a, first statement, semicolon, then next statement would be a is equals to a plus 1, meaning the a variable, we add plus 1 as long as it's less than 10. Once it's done, the while loop will finish. So this is the control flow that allow us to execute that same code multiple times. So I left do while loops out of flux, or the for each, kind of like the for each loop of flux. Do while loops out of flux because they aren't that common and wouldn't teach you anything that you won't already learn from while. Go ahead and add it to your implementation if that makes you happy. So finally, we have for loops. So this loop does the same thing as the previous while loop. So this loop, the for parameter var space a equals to space equals space 1 semicolon, initialize a variable expression. This is also what you would see with JavaScript. For example, for parameter let space I equals to 1, and then this is the condition, the second one, I less than, for example, 10. So while this is true, while this condition returns a boolean true, then you would now set what would happen. It could not be increment like this a equals to a plus 1 could be rewritten as I plus plus for JavaScript. So you could implement this inside of this body. So you would print this a in incremental order while this is less than 10. So as a matter of fact, we can see this in a JavaScript live JavaScript runtime. JavaScript runtime environment website. So for example, for JavaScript, we define I initial variable var is 0. Now while I is less than 10, semicolon, then we do I is equals to I plus 1, semicolon. Then its body would have a, let's say, it will implement, what do you call that body then? Here, print a, then a plus 1. Print I, then I, no. So since we already have print, let's see. Let's run that first. Syntax error. So we do not need semicolon here. Let's see I plus plus then. So this is the main.js then. So since print is not a JavaScript allowed syntax, console.log parameter I would be the right I equals to I plus 1. So this is what we wanna do. So there's really no semicolon then. So yeah, at the end you do not have semicolon. Now we can choose, this is just the condition that will return. If it's true, this condition true, it will this execute. Now, let's say we start at 10 then. So if we run this, execute with exit code 0. Let's say the condition would be I is less than 30, and then I is equals to plus, let's say, 19. 10 and then 29, then it exit the code. So those are the a good basic knowledge. As you can see, we don't have semicolon for plus 1 as well. So this is how you do the for loop. So go ahead and add it to your so this loop again is just a statement that allows you to use the specific block of code repeatedly. And this is also what's good in numbers, you know, whenever you want to calculate and then to get into some type of data repeatedly, whether it's arithmetic or a boolean or logical expression that returns boolean or number or string, this is what you would do. This loop does the same thing as the previous while loop. Most modern languages have some sort of for in, but we didn't do that here again. So most modern languages also have some sort of for in or for each loop explicitly for explicitly iterating over various sequence types. In a real language, that's nicer than the crude C style for loop we got here. So in a real language, though, it's nicer to get, you know, a better syntax for this, you know, less typing like Python does. So this is a note. This is one section I made because of how the implementation is split across chapters. A for in loop needs some sort of dynamic dispatch in the iterator protocol to handle different kinds of sequences. So a for in loop, if we want to implement that, or for each loop, which is usually used in Python, in iterating over various sequence types, needs some sort of dynamic dispatch in the iterator protocol. So since we split that into different chapters, that would be a concession we make here, because that sort of dynamic dispatch in the protocol to handle different kinds of sequences, but we don't get that until after we're done with control flow. So we can go back to that after we're done, representing the control flow in our classes in JavaScript. Now we could circle back and add for in loops later, but I didn't think doing so would teach you anything super interesting. So the for in loop or for each loop is the same. Okay, this is how we do. It's just as well a part of a control program RAM where it allow us to do. It use dynamic dispatch iterator protocol under hood, and it allows us to repeat blocks of code multiple times so that it could execute it could, while it's returning this true value or false value, and then doing an execution as a arithmetic, or it could return a string as well. So for example, here I equals plus 1 so we would, for example, console.log so that log and then a parameter Gareth, for example. Now when we run this, we would see there's a Gareth with each execution. So those could be the return values. Those are just the basic values we could return from each of that. Now functions. A function call expression looks the same as it does in C. So a function, one of the best thing to define a function is how would you able to call that? What does a function represent in terms of expression? So another thing that we have not discussed is that it's just an expression and statement, because for conditional it's also an expression, right? It evaluates to something. Statement do not evaluate to something. A function call is also an expression. So a call expression, to be precise. So whenever you're using function, you're really using, or you're calling a function expression with a parameter, let's say here, of a variable as well. So make breakfast function parameter bacon comma eggs comma toast, closing statement. Now you can also call a function without passing anything to it. Like here, make breakfast. So an expression in JavaScript, it's actually it's just a variable as well. It just occupies something in memory. Now here in us, we can call the expression without an initializer argument. So for a variable, whenever you have a variable, you would have an initializer expression. But for a function, to organize it, to explain it, you would need an initializer argument, but you don't need, so you can just define or call the expression without an argument or without passing any inputs to it. or without editing or modifying state. So unlike in say Ruby, the parentheses are mandatory in this case. So whenever you see a mandatory just open and close parentheses, what we're really doing is just we're calling function without passing any input. So it's just like an initialize without initialize expression, or kind of like an initialized variable. Now if you leave them off, the name doesn't call the function, it just refers to it. So if you leave the it off, it's kind of like a reference error, just like when you have a reference variable error when you don't define the value of a variable. So a language isn't very fun if you can define your own function. So in locks, you do that with fun. Note, I've seen languages that use fn, func, and function. I'm still hoping to discover a functy, or func.io somewhere, or func input output somewhere. Now here, fun space print some parameter a comma b variable, and then inside will be print a plus b semicolon closing body of this function, or closing block rather. Let's call it block now. Now is a good time to clarify some terminology. Some people throw around parameter and argument like they are interchangeable, and to many they are. We're going to spend a lot of time splitting the finest of downy hairs around semantics. So let's sharpen our words. So in order for you to be able to clear what do you really mean at runtime in a programming language, or in defining a language, or the semantics, because language could be confusing if it's just word, with many different interpretation, you need to sharpen your words. You need to explain what that does mean in detail. So from here on out, an argument is an actual value you pass to a function when you call it. So it's an actual value. So a function call has an argument list. Sometimes you hear actual parameter used for this. A parameter is a variable. It's not an actual value. It's a variable that was passed, that could change when a value at the top level or in that variable change. So a variable that holds the value of the argument inside the body of that function. That's why it is related to how when you define a function without an open and closed parentheses, it just refers to it. It doesn't actually call that function with its value or with its argument. So thus, a function declaration has parameter list. So a function declaration has a parameter list. So this is where declaring a function and defining it, just like declaring a variable and defining it, is also different. When calling a function, the function already declared. So you're putting an argument to it. So thus, a function declaration has a parameter list. Others call this formal parameters or simply formas. Note, speaking of terminology, some statically typed language like C make a distinction between declaring a function and defining it. A declaration binds the function type to its name so that calls can be type checked but does not provide a body. So in C, there is actually a function declaration and defining. Again, declare and define for variable. Now, a declaration just binds the function to its type so that calls can be type checked but does not provide a body. So it doesn't need to provide a body. Kind of like doesn't need to provide a value to that parameter. Now, the definition declares the function and also fills in the body so that the function can be compiled. So you're also defining what you want for that function body, what value or what logic you want to execute. You want it to return boolean, nil, string, integer. Since lock is dynamically typed, this distinction isn't meaningful. Since lock is dynamically typed, we can allow any type for that function and then just, have the user impose a type checking in runtime, just like with the error with types we discussed earlier. A function declaration fully specifies the function including its body. So we don't need to be like C, which kind of like a statically typed function. So here, a function declaration fully specifies the function and its body, without having to type check, having the language to type check the return value of the function. Now, the body of a function is always a block or a series of statements. So this is where the statement came from. Inside it, you can return a value using a return statement. So inside it, you can return a value, whether it's nil, string, boolean, or integer, using the return keyword or return space a plus b semicolon. Now, if execution reaches the end of the block without hitting a return, it implicitly returns nil. Now, if execution hit are able to hit the end of the block, so we're not repeating this function, or we're not executing this block anymore, and there's no return value. You did not return string, boolean, integer, or nil. It will return a nil, kind of like an initialize an initialized variable does. It doesn't get a type error issue when parsing it, but it returns a nil value. So if execution reaches the end of the block without hitting a return, the next would be closure and classes. Just a moment. So closures, functions are first class in locks, which just means they are real values that you can get a reference to. So just like a variable where you could call a variable and then have a value that you can return to, reference to, store in variables, pass around, etc. Now these work like fun space and pair parameter a, b. What do you call this? Parameter and argument. So fun add pair with a parameter a comma b. So this is a variable since it's a parameter, and then and this is a variable declaration. We're defining the parameter. Then inside will be return space a plus b semicolon closing scope. And then here font space identity parameter a, and then its scope would be return space a statement. So it has one statement in its scope. Then print space identity with a parameter add pair. So notice we have add the function add pair as a parameter here. Now with that value 1 comma 2. So because add pair execute 1 plus 2 inside its scope statement, then it will print that, or since that since it has a parameter declaration of a and b, since you put a and b 1 and 2 input here, it will output its return value, or y fun io is declared that way. Now since function declarations are statements, you can declare a local functions inside another function. Since a function declaration are statement, you can declare local functions inside another function. Just like this, fun space outer function. So a function is also written in camel case here. Fun outer function empty parameter. So since function, you can declare that without parameter, or since functions declarations are statement, you can declare local function inside another function. Just like this, fun space outer function empty parameter, then its scope would be fun space local function empty parameter, then its scope has one statement, print quote I'm local semicolon, then closing. Then this is what you would return, local function with an empty parameter, but it has open and close parenthesis semicolon. Then closing body or closing scope of this outer function. Now if you combine local functions, first class function, and block scope, you run into this interesting situation. Now if you combine the local functions, the first class functions, the input value as an input to another, the function could be passed as a value itself, so that's first class functions. Local functions means you can function declarations are statements, meaning you can have a function inside a function with a empty parameter. And block scope, you run into this interesting situation in block scope. So in this block scope, fun return function empty parameter with a block scope first statement with a block scope that first has a statement var, and then it has a fun inner function with its block scope one statement which print outside, and then after that you have return space inner. So you do this calculation to inner first with an empty parameter or argument rather. With an empty argument, you print the outside, which is the outside, and then you return the inner. Now after that, when you declare a variable called fn, and then equate that to return function, and then open and close parentheses, so that's important, so that you can call the function semicolon, then thus fn open and close parentheses semicolon, you can return the outside. Just the outside you return, you initialize as variable in return function. So here, inner function accesses a local variable declared outside of its body in the surrounding function, or in its is this kosher? Now that's lot of language have borrowed now that lots of language have borrowed this feature from Lisp. You probably know the answer is Yes, so this is what closure, then this is what the hard part of understanding like JavaScript, React, etc. Because this is where the state came from. So for that to work, inner function has to hold on to references to any surrounding variables that it uses so that they stay around even after the outer function has returned. We call functions that do this closures. These days, the term is often used for any first-class function, though it's sort of misnomer if the function doesn't have to close over any variables. So it is called closure because it often has a variable inside of that function, and it's usually used for a first-class function language such as JavaScript. Though in Python you can also do this because a Python is a combination of a functional programming or prototype programming and a class-based programming object. Now note, uh, Peter J. Landin coined the term closure. Yes, he invented damn near half of the term programming. So as you can imagine, implementing these adds some complexity because we can no longer assume variable scope works strictly like a stock where local variables evaporate the moment the function returns. So going back now to here, as you can see, we could make it a runtime error. Now we'd let you define an initialized variable. But if you access it before assigning to it, a runtime error would occur. It's not a bad idea. So this is what we are saying, that we could make it a runtime error. We'd let you define an uninitialized variable. But if you access it, the variable, before assigning to it, a runtime error would occur. So most dynamically typed languages do not provide, a runtime error if you do not declare the variable. You would usually have to have return an uninitialized or nil. So you would also see this value in database in Python, where this uninitialized variable or not defined, not assigned value to a variable is seen as a nil in a database, a MySQL or PostgreSQL. Now var space a semicolon, the next statement is print space a semicolon, which return nil. Thus, if there isn't an initializer, we set the value to null. Thus, if there isn't an initializer, we set the value to null, which is the Java representation of LOCKSS nil value. Which is just the Java representation of just LOCKSS nil value. Then we'll tell the environment to bind the variable to that value. So here, to be able to implement that, what we discussed in a language earlier, where we return null or nil if the variable is not defined, here's how we could implement that. It's interpreter the Java. We would add this after visit unary xpr method. So here at override, under it is public space object space visit variable xpr method with a parameter xpr that variable space xpr with a block scope return space environment that get parameter xpr that name, and then closing statement, then closing of this public method. So as you can see, we also return something. We return a environment that get with a parameter xpr that name value. So we can also do this in Java, which are returning some method or variable. So this simply forwards to the environment, which does the heavy lifting to make sure the variable is defined. So these are just forwarding to the environment class, which makes sure the variable is defined. So with that, we got the rudimentary variables working. Now we can try this out. Var space a equals to 1 semicolon. Then under it is var space b equals to 2 semicolon. Then under it is print space a plus b semicolon. Now we can't reuse code yet, but we can start to build up programs that reuse data. Now we can't reuse code yet, just like with a control flow program, but we can start to build up programs that reuse data or reuse the variables, right? So we can't reuse the code yet using a for loop, but we could, or control flow program, but we can reuse a data. Now assignment. It's possible to create a language that has variables but does not let you reassign or mutate them. So again, in assignment, it's possible to create a language that has variable but that does not let you reassign or mutate that variable or redefine it. But I mean, a better word would be reassign or mutate. So this is what we are saying in function where you're editing state, modifying state, mutating them or mutating variables, since function is also variable. Haskell is one example. SML support only mutable references and arrays. Variables cannot be reassigned. So in SML, it only support mutable or editable arrays and references to that variable, but it cannot reassign the value of that variable. Now Rust steers you away from mutation by requiring a math modifier to enable assignment. Now Rust, on the other hand, steer you away from mutation. It doesn't, want you to mutate by requiring a math modifier to enable the assignment. Or to the assignment, mutation, modifying, reassigning, those needs to be separated, right? But it has those are synonyms. So Rust steer you away from mutation by requiring a math modifier to enable assignment. Now mutating a variable is a side effect, and as the name suggests, some language folks think side effects are dirty or inelegant. So mutating a variable is a side effect, right? So that's why some language folks think that they are dirty or inelegant. Code should be pure math that produce values, crystalline, unchanging ones, like an act of divine creation. It should not be side effect or reassigning something. Not some grubby automaton that beats blobs of data into shape. It should not be a grubby automaton that beats blobs of data into shape, kind of like putting or bundling it in a class. One imperative grant at a time. So we want an imperative grant at a time. It should be pure math, executing something. That's why you can't reassign a value. It's just an imperative programming. So I find it delightful that the same group of people who pride themselves on dispassionate logic are also the ones who can't resist emotionally loaded terms for their work, like pure, side effect, lazy, persistent, first class, higher order. So those, want a pure logic, an imperative programming without blobs of data or without thinking in a class. Also, loaded their work with pure, side effect, lazy, persistent, first class, higher order, or the things that is a concept of a class or blobbing some data without, just an imperative programming or without representing the binary into a string. Now, LOX is not so austere. LOX is an imperative language, and mutation comes with the territory. Adding support for assignment doesn't require much work. Global variables already support redefinition, so most of the machinery is there now. Mainly, we're missing an explicit assignment notation. So LOX is not austere. LOX is an imperative language. And mutation comes with so adding support for assignment doesn't require much work. Global variables already support redefinition. We just need to support that in a block scope. So therefore, we're just missing the explicit assignment notation. Now, assignment syntax. That little equal syntax is more complex than it might seem. Like most C-derived languages, assignment is an expression and not a statement. So again, that little equal syntax is more complex than it might seem. That's why we have this assignment syntax section. Like most C-derived languages, assignment is an expression and not a statement. So for most C-derived, which were most language are, even PHP, the assignment is not a side effect. It's not an expression and not side effect or statement. As in C, it's the lowest precedence expression form. So again, it's goes back to the precedence and associativity expression. So after logical operator, you would have this precedent expression. So that means the rule starts between expression and equality, the next lowest precedence expression. So again, that means the rule slots between expression and equality, which is the next lowest precedence expression, is this. So note, in some other languages like Pascal, Python, and Go, assignment is a statement. So in Python, assignment is actually a statement, or having an equal, it is considered a statement for them. Now, this says an assignment. So here, first expression is mapped to assignment. So this was the grammar, and then assignment is is mapped to identifier, then quote equal, then assignment or equality. So this grammar says an assignment is either an identifier followed by an equal and an expression for the value, or an equality and thus any other expression. Later, assignment will get more complex when we add properly setters on objects, like instance.field equal quote value semicolon. So again, this says an assignment is either identifier followed by an equal and an expression for the value. So identifier equal then expression for the value, or an equality and thus any other expression. Later, assignment will get more complex when we add property setters on objects. So it will get more complex, this identifier, the equal, when we add the classes and methods and the setter for that method or for the field of the class, such as instance that field equal called value statement. The easy part is adding the new syntax tree node. So here in tools.generate.ast.java, in main method, we will start with the easy part. In main method, we will add this quote assign space colon space token space name comma space xpr space value. Now, this is the start of preparing for assignment. It has a token for the variable being assigned to. So it has a token. That means that assign space colon, space token, space name, comma, space XPR, space value has a token for the variable being assigned to and an expression for the new value. And it, aside from token, it should have the expression for the new value because that's our grammar for the assignment. So after you run the generator, ASD generator to get the new XPR that assign class, swap out the body of the parser's existing expression method to match the updated rule. So here in parser.java in expression method, so private space XPR space expression empty parameter. It's block scope. The first statement is return space assignment empty method or return assignment method. Open and close parenthesis semicolon. So this is the same allowable logic we have in our locks. Just an open and close parenthesis. Here we return assignment. So here in expression method, we return that. So as you can see, we return the assignment in expression method in /parser.java here. So here is where it gets tricky. A single token look ahead recursive descent parser can see far enough to tell that it's parsing an assignment until after it has gone through the left hand side and stumbled onto the equal. So the look ahead recursive descent parser can see far enough to see that it is an statement until after it has gone through the left hand side and stumbled onto the equal. You might wonder why it even needs to. After all, we don't know we're parsing a plus expression until we finish parsing the left operand. So the difference is that the left hand side of an assignment isn't an expression that evaluates to a value. It's a sort of a pseudo expression that evaluates to a thing you can assign to. So again, the difference is that the left hand side of an assignment isn't an expression that evaluates to a value. Right? The left hand side of the equal. It's sort of a pseudo expression that evaluates to a thing you can assign to. Consider var space a equal code before semicolon and then a equals to code value semicolon. On the second line, we don't evaluate a, which would return the string code before. So on the second line, we don't evaluate a, which would return the string before, that was the initial value. We figure out what the variable a refers to so we know where to store the right hand side expression's value. So that's what we mean here. We figure out where is this located in memory so that we could store the right hand side expression we want to store for that address in memory. Now, the classic terms for these two constructs are I value and R value. All of the expressions that we've seen so far that produce values are R values. So all of the expression, just before the assignment is introduced are R values. And I values evaluates to a storage location that you can assign to, just like with this classic var space a equals code before semicolon, and then an I value a is equals to code value, which refers to a storage location that you can assign it to. Note, in fact, the names come from assignment expressions. I values appear on the left side of the equal in an assignment, and R values on the right. So in fact, that means the I and R value come from the assignment expressions. So there is also an assignment expressions that we would have liked to add in the preceding and grouping. So these assignment expressions, which means that the I values appear on the left because it's evaluating a storage location in an assignment. And the R values in this assignment expression or the regular expression are on the right. See, we want the syntax tree to reflect that an I value isn't evaluated like a normal expression. That's why the XPR.assign node has a token for the left hand side, not an XPR. So again, we want the syntax tree to reflect that an I value isn't evaluated like a normal expression. So we want to reflect this I value onto the syntax tree, or the one that's generate a tree. That's why the XPR.assign node has the token for the left hand side, not an XPR. So that's why the XPR.assign node has a token for the left hand side, this token name, XPR value. The problem is that the parser doesn't know it's parsing an I value until it hits the equal. In a complex I value that may occur many tokens later. So in a complex I value that may occur many tokens later, such as here, make list open and close parenthesis dot head dot next space equal node semicolon. So note, since the receiver of a field assignment can be any expression, and expressions can be as long as you want to make them. So an expression, right, can be as long as you want to make them. If you have like a nested class, if you already implemented blobs of fields later, then it may take an unbounded number of tokens of look ahead to find the equal just before the equal. So we only have a single token of look ahead. So what do? We use a little trick, and it looks like this. So we would add this in parser.java, doc/parser.java, add after expression statement method. So here, private space XPR space assignment, empty parameter method. Then its body, we will have first we have statement, and then an if with block of statement, right? So it has a parameter conditional, match parameter equal. And then after that, we have a nested if here. If with a conditional XPR space instance of space XPR that variable, with a block scope with a 2 series of statements. And then after that, we still have the statements error with the parameter equals comma code invalid assignment target dot code closing statement, then closing block scope of that first if with a conditional match parameter equal. And then last would be return space XPR. Notice it still follows the return thing, because again, a function or a method is just returning a value from that input. And then this thing, we initiate variable, and then we have nested if, are just so we can implement a control flow, or we can repeat a code and do this logic, branch something, go to the other part of the code, which is branching, which is also what the if else is and the for loop is. It's a control flow statement. So this control flow statement is a series, consists of a series of statement and expression that will only be executed if some part of the code met that. So it's a control flow statement. So most of the code for parsing and assignment expressions looks similar to that of the other binary operators like plus. So again, most of the code for parsing an assignment expression looks similar to that of other binary or operators like plus. We parse the left-hand side, which can be an expression of higher precedence. If we find an equal, we parse the right-hand side and then wrap it all up in an assignment expression tree node. Now we report an error if the left-hand side isn't a valid assignment target, but we don't throw it because the parser is in a confused state. He's in a confused state where we need to go into panic mode and synchronize. So again, most of the code for parsing an assignment expression looks similar to that of the other binary operators like plus. So most of the code for compiler for parsing an assignment expression looks similar to the plus, which is the concatenation, has the arithmetic and concatenation. We parse the left hand side, which can be any expression of higher precedence. Then if we find an equal, we parse the right hand side and then wrap it all up in an assignment expression tree node. So first we parse the left hand side, which can be any expression of higher precedence. Now if we find an equal, we parse it just like an assignment expression. Note, we report an error if the left hand side isn't a valid assignment target. But we don't throw it because the parser isn't in a confused state where we need to go into panic mode and synchronize. So again, we report an error if the left hand side isn't a valid assignment target. But we don't throw it because the parser isn't in a confused state where we need to go into panic mode and synchronize. So again, we report an error if the left hand side isn't a valid statement target. So if the statement target is not actually pointing to an assignment expression, we report an error for that. But we don't show it because the parser isn't in a confused state where we need to go into a panic mode and synchronize. Now, we don't throw because we could, just throw this just like with the panic, if it's a panic mode or the type of error such as panic mode, we could just throw it and not, catch, we're still catching it, we're not throwing it. Because it's not like an issue that would affect the memory. So we don't throw it because parser isn't in a confused state. It's not in a confused state, or it's not, the semantic are still intact, or we need to go into panic mode and synchronize. So it's not the right error. We just report an error. One slight difference from binary operator is that we don't loop to build up a sequence of the same operator. Since assignment is right associative, we instead recursively call assignment method to parse the right hand side. So again, one slight difference from binary operators is that, or from binary operators, which is the same parsing technique with assignment for other languages, since one slight difference from binary operators is that we don't loop to build up a sequence of the same operator. So the slight difference from our binary operators, where we prepare the parsing for that, is that we don't loop to build up a sequence of the same operator, because we're using an assignment operator, not binary operator. Since assignment is associative, we instead recursively call assignment to parse the right hand side. So going back to the associativity, the assignment is actually right associative compared to left associative, just like with the binary operators. The trick is that before we create the assignment expression node, we look at the left hand side expression and figure out what kind of assignment target it is. We convert the R value expression node into an I value representation. Now this conversion works because it turns out that every valid assignment target happens to be a valid syntax as a normal expression. So this this strategy worked because it turns out that every valid assignment in this math thingy target happens also to be a valid syntax as a normal expression. Consider a complex field assignment like new point, parameter x plus 2 comma 0, closing new point with a condition x plus 2 comma 0, then closing condition point y. So this new point variable has point y. So, or it's actually a method that has a variable y that we would equate to 0. So new point parameter x plus 2 comma 0, closing parenthesis that y equals 3 semicolon. Now the left hand side of that assignment could also work as a valid expression. So the left hand side of that assignment could also work as a valid expression. Like here, new point parameter x plus 2 comma 0, closing parenthesis that y semicolon. So that left hand side could also be a valid expression, without definition. Now the first example sets the field, the second gets it. So that's the set and get field into this inside of this method new point. So that's how we could think about its representation. This means we can parse the left hand side as if it were an expression, and then after the fact produce a syntax tree that turns into an assignment target. If the left hand side expression isn't a valid assignment target, we fail with a syntax error. That ensures we report an error on code like this: a plus b equals c semicolon. Now, way back in the parsing chapter, I said we represented parenthesized expression in the syntax tree because we'll need them later. This is why we need to be able to distinguish these cases. A equals to 3 semicolon, okay. And then open parenthesis a close parenthesis equal 3 semicolon is error. Right now, the only valid target is a simple variable expressions, but we'll add fields later. So way back in the parsing chapter, I said we represent parenthesized expression in the syntax tree. So in the syntax, we need to report an error for a parenthesized expression, such as this: open parenthesis a closing parenthesis equal 3 should be an error. Because of this, it's related to this assignment thing. So right now, the only valid target is a valid variable expression, but we'll add fields later. So now the only valid target is just a variable, but how about the fields later? The variable inside the class. The end result of this trick is an assignment expression tree node that knows what it is assigning to and has an expression subtree for the value being assigned. all with only a single token of look ahead and no backtracking. So assignment semantics. We have a new syntax tree node. So our interpreter gets a new visit method. So whenever we have a new syntax tree node, again our interpreter should get a new visit method, or we're representing that tree node into a visit method, or one of the visit method. We would add in interpreter the Java. So here we would add after visit var stmt method, add override, under it is public space object space visit assign xpr with a parameter xpr that assign space xpr, and its block scope, it has 3 statement. Object space value equal evaluate parameter xpr dot value closing statement. Then next statement would be environment that assign parameter xpr dot name comma value closing statement. Then next statement would be return value. For obvious reasons, it's similar to a variable declaration. It evaluates the right hand side to get the value, then stores it in the named variable. So just like with the variable we discussed, where it points to a location of the value, and then it evaluates the right hand side, which is the value, and then stores that value into the name variable or the address on the left side. It's the same method here. So public space object space visit assign xpr with the parameter xpr that assigns space xpr with the block scope object space value space equal evaluate parameter xpr dot value closing statement. The next statement is environment that assign, so parameter xpr dot name comma value closing statement. So we assign the xpr we assign the value of the inside the environment as the xpr dot name comma value. Then the next would be return space value. So after that, for obvious reasons, it's similar to a variable declaration. It evaluates the right hand side to get the value, then stores it in the name variable. So instead of using define method on environment, it calls this new method. So instead of using the define method on the environment, it calls this new method. We would add this after the get method. So void space assign with the parameter token space name comma object space value with a block scope. So it's a control flow program. So if condition values that contains key parameter name that lexim, its block scope would be values that put parameter name that lexim comma value closing statement. So that's the first series of the statement in this if control flow. Then last would be return semicolon statement and closing block scope. And then another statement here is throw space new space runtime error parameter name comma code undefined variable plus name that lexim plus code dot, and then closing statement or closing throw statement, and then closing method. So this is in logs-environment.java after the get method. Now the key difference between assignment and definition is that assignment is not allowed to create a new variable. In terms of our implementation, that means it's a runtime error if the key doesn't already exist in the environment's variable map. So again, the key difference between assignment and the definition or definition parser interpreter or definition interpreter and environment is that the assignment is not allowed to create a new variable. So the definition, though, interpreter, parser, and environment allows to create a new variable because you're defining a variable. Here, it's not allowed. So in terms of our implementation, that means it's a runtime error if the key doesn't already exist in the environment's variable map. So if the key, if the variable is not defined, and then you're equating it to it, therefore it will be a runtime error. That's why we throw space new runtime parameter name comma undefined variable here. Now note, unlike Python and Ruby, locks doesn't do implicit variable declaration. So we don't do the implicit variable declaration, like, declaring a variable without actually writing one. We don't do that here. We need to write one and then semicolon and end it with a statement to return nil. We do not do implicit variable, just like with the statement we discussed earlier, whereby we actually have those type check for a function. If that does not define, then the C will return an error, right? So the last thing visit method does is return the assigned value. So again, we need the visit method for us to represent this in a method to produce a syntax tree. So the last thing for this visit method does is return the assigned value. That's because assignment is an expression that can be nested inside other expressions. Like so here, var space a equals 1 semicolon, and then under it would be print space a equals 2 semicolon, which prints 2. So interpreter can now create, read, and modify variables. So this is actually what makes our interpreter do CRUD. Create, read, and modify the variables. Create, read, modify, or update. It can also delete. So modifying a variable is also a type of deletion. It's not just an explicit delete word, just like we have with CRUD in a database. So it's about as sophisticated as early basics. So the early basic language, it's as sophisticated as that. Global variables are simple, but writing a large program when any two chunks of code can accidentally step on each other's state is no fun. We want local variable, which means it's time for scope. So scope really is what we defined in the earlier part of a language, is actually what implements a local variable. And a local variable is what we usually want in application. We want to avoid a global variable. And we want to do this local variable so that the code should not step into each other's toes. Or two chunks of code could not accidentally step on each other's state or its value while it's executing at runtime. Now we do have strategies for like a design pattern so that we can avoid that interacting our classes at runtime or objects or functions at runtime. But here we're technically saying defining how this language will define the function and state and how it would be interacted at runtime. So we want local variables, which means it's time for scope. Note, maybe a little better than that. Unlike some old basics, locks can handle variable names longer than 2 characters, which is in Lisp. It cannot actually handle a variable that is larger than 2 characters. So it's time for scope. A scope defines a region where a name maps to a certain entity. So in order to implement these many local variables, which usually you would receive as a question in an interview on how you would manage the state, it's really this. So using a scope and local variables so that chunks of code cannot accidentally step on each other's state. A scope defines a region where a name maps to a certain entity. Or this is now
how we define, waiting list, patient, or any part of logic that we could technically express in infinite way in binary that we can now express in a code or a business logic such as transactional finding. A scope defines a region in code where name maps to a certain entity. This is how you map the input, process, and output. So multiple scopes enable the same name to refer to different things in different contexts. Now you have this the multiple scopes enable the same name to refer to different things in different contexts of the code or in different data inputs for that particular entity. So, different method and a different part of the code at runtime could be different meaning in different um, contexts. So, in my house, Bob usually refers to me. But in your town, you know a different Bob. Same name but different dudes based on where you say it. So here is where the lexical scope comes, or the less commonly heard static scope. It's a specific style of scoping where the text of program itself shows where a scope begins and ends. So a lexical scope it is a scoping where it's a style of scoping where the text or the program tells you where that part or where this name map to this entity start and where it ends, and where this name is different meaning in different parts or region of the code. In logs, as in most modern languages, variables are lexically scoped. So most languages or variables are actually lexically scoped as well, meaning it tells you where that style of scoping, where that begin and where that end. So when you see an expression that uses some variable, you can figure out which variable declaration it refers to just by statically reading the code. So when you see an expression that uses some variable, you can figure out if it uses lexical scoping, which variable declaration it refers to just by statically reading the code. So note, lexical come from the Greek lexikos, which means related to words. When you use it in programming languages, it usually means a thing you can figure out from source code itself without having to execute anything. So you can now figure out where this block of code start and end without running it in memory or without inputting some data in it. Now, lexical scope come onto the scene with ALGOL. Earlier languages were often dynamically scoped. Computer scientists back then believed dynamic scope was faster to execute. Today, thanks to early scheme hackers, we know that isn't true. If anything, it's the opposite. Dynamic scope for variables live only in some corners. Emacs leaves default to dynamic scope for variables. The binding macro enclosure provides it. The widely disliked with statement in JavaScript turn properties on an object into dynamically scoped variables. For example, this blank scope var space a equals to code first semicolon, next statement is print space a semicolon, will print first, then closing block scope, and then another block scope, first open semicolon. So whenever we have open semicolon bracket, that's the start of the block scope. So here, same var space a equals to code second, var space a equals to code second semicolon, then under it is print a semicolon. So this same a variable has a different string value in different scope. So that's where the local variable is. Here we have two blocks with a variable declared in each of them. You and I can tell just from looking at the code that the use of a in the first print statement refers to the first a and the second one refers to the second. So here, first block, a map to first, then second block, a map to second. This is in contrast to dynamic scope, where you don't know what a name refers to until you execute the code. Blocks doesn't have dynamically scoped variables, but methods and fields and objects are dynamically scoped. Meaning, When it's dynamic, you don't know what the name refers to until it executes the code. That's why it's hard to know what the code means is. So here, class saxophone, then inside would be play method. Let's continue with this tomorrow.